Welcome, everyone. My name is James Mancini, one of the original founders of Netreo, and today we're going to be talking about how to solve some of the challenges of managing IT at scale. All of the attendees are muted, so if you think of any questions during the presentation, please make sure to enter them in the questions section of the GoToWebinar interface, and we'll be sure to answer them for you as we go along. So, some of the common challenges that customers report when trying to scale up their management may be familiar to you. In any large environment, there's often a legitimate need to gather data from different places around the network and even around the world. A single central collection point no longer really works at that scale. However, a common problem with this is running into the limitations of the monitoring software itself. Now, this could be a problem with performance at that scale, or it might be a problem with the flexibility the solution offers. Very often, it's also a problem with the administration requirements for handling these complex environments. And one of the most common complaints we hear is that the sheer volume of alerts constantly flooding out of the system is simply overwhelming the command center or the engineers. So let's take a deeper look at these and see what the best current tools are to address them. One of the biggest challenges, and one that drives many of the others, is the need for distributed data collection. So in large environments, it's common to have multiple large data centers or to have remote compute resources that need to be monitored, whether those are located in remote corporate locations or in virtual private cloud data centers. One of the key reasons for this is the requirement to collect performance metrics and latency locally, so the statistics are unaffected by things like network topology or load. So for example, if I've got a data center serving APAC customers that's located in Seoul, it doesn't make a lot of sense to measure round trip latency or application response time from California, knowing my international data lines are probably my lowest bandwidth and highest latency connections. The statistics are going to be much easier to interpret and compare if each application is measured from where the users are located, but we need to be able to do this without having to have a lot of different points of administration. A key aspect of this is the ability to cache the data during a connectivity outage. So if I have a remote location serving local customers and my international link goes down or there's a routing disruption on my internet VPN, I don't want to have big blind spots and gaps in my data. So it's important that the local collector be able to continue monitoring and catch up when the link reconnects so I don't get those gaps in my database and my reports don't have large gaps of blind spots where I have no idea what was going on at the time. Also, being able to use these kind of distributed resources to collect the data can be a big advantage when scaling. So if I can offload some of the resource intensive collectors like NetFlow or Syslog to dedicated systems without losing the advantages of a single user interface into all that data, that's obviously very valuable as I scale the enterprise up. Another factor to consider is that removing that intensive data collection traffic from my long distance WAN links. So if all the servers in my sole data center, for example, are sending their log data to a local system, which is then just forwarding summaries and report data as needed, I've taken the high bandwidth load off my longer lines and kept that traffic mostly local, which is going to have a noticeable performance impact. Now, our approach uses what we call service engines, which are remotely deployed appliances, either physical or more commonly virtual appliances, that offload functions from our central OmniCenter platform. The service engines can be deployed to perform several different tasks or can be specialized depending on the needs of your specific environment. So I can deploy a service engine, for example, to offload collection of syslog or Windows event log data to keep that local to the servers, as we talked about. Another example might be to deploy one to collect traffic and performance data like NetFlow or IPFix to keep that data off my WAN links or to distribute the load in a really large environment. These protocols can be very intensive in a large environment, and so the ability to distribute them around the network can really help me out. I can also distribute the basics of performance and availability monitoring to a service engine. For example, if I have an isolated DMZ segment that I don't want to open the firewall to, I can monitor that locally and collect that data across a secure API connection instead of having to open all the different monitoring protocols through the firewalls. I could also use this to do something like monitor a remote data center on the other side of the world to make sure that all my stats, again, are local to where the users are actually at. This flexibility enables us to deploy the solution in several different ways depending on the specific requirements of the customer or the environment. So let me show you a few different examples of how that works. The most basic model is the traditional on-premise model, where most of the performance data is collected by interrogating the devices directly. So this is the model we're all familiar with. But in a large enterprise environment, this means data has to be collected directly from remote systems or cloud-hosted devices, which may not be ideal from a security, configuration, or a bandwidth perspective. So with the service engines, now I can collect local data locally using a remote collector to collect the data from those resources, which keeps the high bandwidth protocols local and then pass that data back to the monitoring system via an encrypted API for analysis, storage, and alerting. This allows us to overcome some of the bandwidth or security issues we might otherwise deal with and still keep our data and access to that data on premise. So this approach minimizes the bandwidth required and keeps the traffic local as much as possible, um, but it allows us to maintain our security profile or our regulatory profile if we need to keep that data in a specific location. We can also use as many different service engines as we need to cover all the different remote data centers or cloud hosting providers. But even so, all of those alerts, reports, and the UI can be kept on premise. So with our solution, if the connection to a remote polar is lost, it'll cache that data to send to the primary system once the connection is restored. So we'll not lose visibility and all the configuration and software updates will still be handled centrally. Of course, we can use the opposite model as well if that makes more sense for the environment. So this is how most SaaS-based monitoring systems work. There's a collector or device or agent that's on premise, but the bulk of the storage in the UI is handled in the cloud. Of course, cloud resources are monitored directly from the cloud here, so there is some collection that's done locally. And there could, of course, be multiple collector devices in different locations or different VPCs around the world. Now, this is much more common for web-centric organizations that are heavily cloud deployed. What we see in most large enterprise is that they're not comfortable with the security implications of putting all of the data storage in the cloud. But you've got the flexibility to do that. You can really choose whichever deployment architecture fits your environment and regulatory requirements the best without adding a lot of administrative overhead and complexity. Let's talk about that for just a second. So a lot of the issues that surround software scaling are based on the model that was used to develop that solution. For example, management software has traditionally fallen into one of two kind of large categories. There's easy to use basic software that's slick and fast, but was probably never designed to truly scale. And then there's things like the big four legacy systems that are very expensive and confusing and very difficult to customize. And in the first category, these are typically Windows-based systems designed for small environments. So these are very common at small to medium businesses. And as organizations grow, often they come along for the ride. These solutions use the approach of adding additional servers to scale, but they usually run into issues with performance and admin overhead. So for example, as I add new servers, I've got to deal with Windows patching, licensing, antivirus, and the maintenance requirements. They're all scaling up at the same rate we're adding servers. And performance often suffers as well, which really limits the maximum scale you can really manage with that kind of solution. They also sometimes fall victim to their target audience, and the UI that worked great for managing 100 servers or routers suddenly becomes a huge pain when we're trying to manage thousands or even tens of thousands of devices. Any software solution that requires you to implement changes one device at a time, for example, has no chance of being able to handle a large global network. Many of these solutions also sell unlimited licenses, which seems appealing as it should allow you to add as many devices as you need. But of course, there's a catch, which is it's only as many devices as one server can handle. And in a lot of cases, that's a lot fewer than you might think. One software solution we tested, in fact, started to have serious issues in only 1,500 devices on a single server, and that was without adding a lot of complex service or application checks or even running NetFlow. One company's design guide, in fact, only recommends a maximum of 500 devices per server. So you may end up with a very large number of servers you have to support in order to be able to monitor your network with that kind of a system. Now, in the second category, we've got those old school legacy big four dinosaur type solutions, which are designed to handle very large environments. But their user interface is best described as arcane and cumbersome in most cases. And even small changes or customizations to those systems can be very expensive and can require specialized training or consultants. It's important to understand that that's actually by design, since most of the companies that make those big four systems make a lot more money from their service and consulting operations than they ever do from selling the software itself. So this means a lot of companies end up with a platform that never really gets fully implemented before it has to be upgraded. One of our customers, in fact, spent 3 years and over $2 million trying to implement one of those solutions, having to start over twice due to upgrades. And then they finally had to abandon it and change directions because it never did finally get completed. It never got to the point where it was actually monitoring and sending out the reports and the alerts that they needed. And that's not even mentioning the ongoing licensing costs of some of these platforms. Now, it makes intuitive sense that the larger your environment is, the more administration is going to be required. But it's important to try and minimize that if you want to scale up. So A recent study by Gartner showed that the number of devices that a single administrator was expected to manage has gone up by almost 75% over the last 3 years. And then that number is expected to increase. So it's key to make sure that as the size of the environment scales, the amount of work required to manage it doesn't scale with it at the same rate. We need to make sure that the operators and engineers have easier lives if we want to make them capable of handling more and more systems under management. If provisioning a new system means they have to go to 3 different consoles to get the new system added to monitoring, that's a task that's less likely to get done in a timely fashion or even done at all. So another good example of this is software updates. One company that makes a very popular Windows-based management platform requires that if you have multiple servers monitoring your environment, they have to be updated in a precise order or the software update will fail. So this means many hours spent running and downloading installers on different systems in a very particular order and doing it for each of the different modules you might be using, like configuration management, NetFlow, virtualization, or logging. One of our customers reported that when they were using that system, a software update often meant spending multiple nights in maintenance windows trying to get all the updates timed correctly and making sure everything was still talking to each other afterwards. So how is that ever going to scale in an environment that requires 10 or 20 or 50 management servers? Maintenance spend also goes beyond just the cost of the software license, because we need to think about things like how many full-time employees do we need just to manage the management platform itself? If I have to have 50 servers to manage my environment because of the scaling limitations, how much is OS licensing and maintenance going to add to my cost of ownership? And that brings up a related point. When you're looking at large scale solutions, you need to watch for the hidden costs because they can really add up. So for example, how much does the hardware for those 50 servers cost? And even if they're virtual, you're still going to have to allocate or buy the CPU, the RAM, the storage, and possibly even VM platform licensing. There's also the question of database requirements. Many systems require a third-party database to be able to scale up, and then that software has to be bought, provisioned, licensed, and patched separately, and then clustered for redundancy. So once all that's in place, how many extra employee hours a month are we using just to hold up the back end for this system? Now, our approach to solving this challenge is to try to keep administration, reporting, and configuration centralized so that we can make scaling simpler. By making sure there's a single user interface for all of these tasks and a UI that's designed for scale, we can really remove the requirement to create custom web pages, access multiple user interfaces, or learn scripting languages to manage and maintain the platform. So this allows you to scale faster by deploying service engines as needed with just a few clicks, while everything is managed and accessed from the same centralized web interface that you're used to. So, for example, our software update process is designed so that you can either fully automate and schedule it, or with a single click, you can download and install the latest versions without disrupting service. And then those updates will automatically get pushed out to all the different service and remote collection engines. So this process is completely seamless. We also take a distributed approach to this problem by making sure the remote collectors, our service engines, are doing much of the heavy computational and database work. So while you can get all your data from the single central console, the heavy lifting gets spread around some, which helps to scale as we add additional resources to the environment and really allows you to scale up to some of the largest network environments in the world. Our appliance-based approach also means there's no external databases to administer or provision, no operating system or antivirus requirements to keep up with. And our built-in automation is designed to make provisioning simple without manual intervention. So even in highly dynamic environments, the solution can be deployed in days instead of months or years, and it can stay in sync even at the pace of DevOps environments. So let's talk a little bit about how that automation is going to help us keep up to date. One of the keys to success in scaling is automation, because automating the monitoring lets us make sure that the monitoring system is up to date even when I'm deploying resources dynamically across thousands of locations and multiple clouds. So we have a number of different ways to do this, and we provide a number of different APIs that allow you to link things like provisioning process automation or CMDB directly into the monitoring configuration, or automatically discover resources even if they're cloud-based. And once our platform locates those resources, we can then drive that configuration forward using rules to define and identify the device type, category, business workflows, and templates that we can use to control every aspect of the monitoring configuration with no manual intervention. We call this process auto configuration, and it comes with a set of rules to get started, which you can easily customize or create additional ones to fit your environment. And you can use these to set things like device attributes, like category, site, business workflows, based on any of the different device criteria, including things like what process is running, what ports are open, what the device's name, or where it's located. This makes sure that there's no manual provisioning process to make sure the device is in the correct report. They always get the right settings and all the right alerts applied, so we don't end up in a situation where a newly provisioned system goes down and nobody found out about it because somebody skipped a step in the monitoring provision process. Now, these rules are automatically applied to devices as they're discovered in the environment, regardless of which method is used to add them in or what platform they're running on. And they can also be reapplied as desired. So if we want to make sure everything stays locked to our configuration, we can easily enforce that. Now, using those criteria that we set with the auto config engine, we then dynamically apply all of the relevant settings via a cascading template system. So what this means is that all the different settings we need applied to the new device are applied without manual intervention. So if, for example, a new SQL server coming online could not only get the basic Windows server settings that we want, but it would also get any SQL specific application checks and settings and make sure that the SQL team gets notified whenever there's a problem with it. And if the database is named production, we can add extra notifications if that's what you want. You can also use these templates to do things like define authentication, escalation, and even active response automation actions. So you can take automated response in the event of an alert or a failure. We can do automatic responses like restarting services or rebooting servers or provisioning additional resources. It's a system that's designed to be flexible enough to meet the needs of a large global enterprise customer, but still being simple enough that a small IT department can use it without a lot of training or dedicated personnel. So these are all things that you can customize, not things that you have to hire consultants to handle for you. Now, alert overload is something that most administrators have dealt with at one time or another, but it becomes more and more of an issue as the environment scales up. So some of the most common complaints that we hear are things like your inbox, phone, chat apps are all exploding with notifications, sometimes hundreds or more of them a day. And at that rate, no one can possibly hope to keep up with them, much less make progress on solving any of the underlying issues. As a result, the operators and engineers start ignoring or even filtering out these alerts, which leaves us to wait for user complaints when a production application fails. Ignoring alerts like this is really asking for trouble because somebody someday is going to inevitably ignore the wrong alert, and you're going to have a major outage on your hands that could easily have been prevented. When the users call the help desk because the last member of the database cluster fails, you're already very deep in the weeds. So this can even be worse than not having monitoring in place because management might feel secure that things are being watched closely when the reality is as good as being blind. And this means that organizations with multiple advanced monitoring systems in place are often stuck in firefighting mode, reacting to alarms as they occur without ever really getting ahead of them and preventing these outages before they can affect users. And in some cases, they're even missing issues because critical alerts can easily be lost in the avalanche of noise coming out of the system. So how do we keep everything well monitored while not flooding our command center with alarms? As a general rule, what we recommend is reserving active alerts for actionable items only. And what we mean by this is that if we're not going to react to a specific notification as soon as it comes in, we probably shouldn't even be alerting on it. So for example, if you're getting alerts when hard drives reach 90% utilization and then you're just ignoring them because it's not urgent, two things are going to happen. First, you're sooner or later going to get server failure because you forgot to circle back on that alert before the drive filled the rest of the way up. And second, you're conditioning yourself and your teams to ignore those alerts. And I've already mentioned what can happen when you do that. So instead, what we suggest you do is that you use detailed reports. So for example, every morning I get a list of servers with the lowest free drive space, and I know if I deal with the top few entries on that list, I'm going to get to sleep through the night. But a key point for making that approach work is to schedule and automate these reports so nothing gets missed. So our platform is designed so that anything you can view in the web interface, you can turn into an automated report with just a few clicks. So this is really easy to do, even without special training or SQL knowledge and without having to use external reporting tools like Crystal Reports that are generally just a pain. Another thing to consider when you're really scaling up is that during a major outage, you need to be able to reliably communicate what's going on to all of the different teams and stakeholders. So the monitoring system needs to be set up so that it can address exactly how you're going to get notifications to people, especially factoring in the difficulties inherent in a mass outage. So for example, email and SMS are usually the foundations that most notifications are based on, but those might be impacted during a crisis or simply saturated with different kinds of alerts and notifications. So let's think about some alternatives. For example, mobile app push takes an entirely separate path from email, and those can even be initiated from the cloud so that the state of your internal networks or systems can't affect it. We also strongly recommend using API integrations with team communication platforms like Slack or Spark or others. Communication platforms like that have a lot of real advantages, and One of them is that all the members of the team are aware and informed of what's being done, when and by whom, and there's a perfect record of everything that was sent and who sent it. And generally, everyone on the team will get those notifications at nearly the same time. So it's easy to see who's working on a problem and be updated with the latest status that way. It's also a really good idea whenever possible to centralize all those alerts and roll them into a single dashboard. And the reason for this is that duplicate alerts and conflicting status that come from multiple tools can easily confuse engineers that are working on the problem or even lead them down the wrong paths and delay resolutions. One of the worst case scenarios is when you have a team that turns over a outage to a different team, and then eventually it gets turned over to another team and then comes back to the first team. This is just creating a huge delay in recovery time, and a lot of the times we find that's caused by confusing information coming from different tools. But it can also provide a single point of acknowledgement and kind of a single truth that everyone can work from. So you have kind of a shared view of reality that will help communication between those teams, especially during a crisis. It can also help to eliminate information silos. So one of the things that we say as a best practice is that you shouldn't let teams do their own monitoring exclusively. In fact, it's highly encouraged to give them a view of what the command center sees, but it's not okay to let them do the monitoring instead of the command center, because teams that do their own monitoring with no oversight tend to hide their dirty laundry. And they also tend to apply temporary fixes, which results in more outages, longer outage times, and a higher percentage of recurring outages. And because there's no oversight, senior management is often unaware of the number or scope of these outages. So another thing that we can do is to make sure that we're leveraging other operational systems that we're already using. So for example, integrating with notification managers can simplify on-call schedules and provide a way to distribute alerts that's not dependent on passing a pager around or internal mail infrastructure, for example. Many organizations will also be using a ticketing or ITSM system like ServiceNow, and you'll want to make sure that your plan and configuration includes how you should use those tools during a crisis and how to integrate them with the monitoring and alerting systems. You should also consider integrating your monitoring system with your CMDB or inventory systems, which can help to make sure that new systems are monitored quickly, of course, but it can also help by making sure that things like decommissioned systems or configuration changes don't get missed and trigger false alarms. Now, we also recommend that you consider using information radiators to share status information to assist communications during a crisis. So an information radiator is just a system designed to display status information in a public area, like a monitor on the wall of a hallway that everyone has to walk through. So you can display things like application views or more technical ones depending on the audience, but this allows you to keep all of your teams in sync, not just for status data, but also useful operational metrics like response time or transaction velocity. And our system is designed to give you an easy way to do this via custom dashboards and business workflow summary data for exactly this purpose. Using information radiators also allows you to actively demonstrate core team values, namely that the team has nothing to hide from visitors, customers, or stakeholders, and nothing to hide from itself because it is acknowledging and confronting the problems. This can help build trust between departments as well as aid in faster problem resolution. Now, one of the easiest ways to reduce that flood of over alerting is to take advantage of built-in technologies like root cause detection. Automated root cause detection is going to help considerably because it eliminates a lot of possible causes and drastically reduces the number of alerts generated during a major incident, which again reduces distractions and avoids a lot of unneeded troubleshooting time. By building a topology or dependencies into the tools or letting the tool discover it, the tool can determine, for example, that the reason all the remote devices at a particular location suddenly went unreachable is because of the WAN router going down. And instead of sending out notifications for every single remote device separately, every switch, every server, every application, every wireless access point, every storage array, I can instead get a single alert that points me to the WAN router. You can also use things like incident management rules to handle special cases. So for example, one of our customers had a lot of remote locations and many of them had old low speed lines. Now, when they ran out of bandwidth and started having problems with too many users at that location, they'd order replacement lines, but those upgrades would often take a month or more to get installed. So they put in a rule that simply said whenever the monitoring system sees a bandwidth issue on a site that already has an upgrade scheduled, send an email to the branch manager to let them know that IT is aware of the problem and the new circuit is on order. By doing that, they managed to reduce the calls into the help desk for that issue by 80% with just a simple rule like that. Now, Our tool also builds in tools that are specifically designed to help you tune your alerts so you can identify what we call the noisy birds. This is what we like to call like the few configured alerts that are responsible for a very large or disproportionate amount of alerts, or those where an adjustment to the sensitivity of the alarm might be required. You can use things like template baseline reports to see exactly which alerts are being generated by your configuration templates, and you can make changes to those templates directly that'll then be automatically rolled out to all of the devices where that template is applied. So one single point of configuration change can then roll out to hundreds or thousands or tens of thousands of devices with no further manual intervention. Also, things like our notification summary reports are helpful to see exactly what alarms are going out and get a count of how many alarms are coming from each device or each type of service check or threshold alarm. And these can be scheduled to run on an automated basis. So every week or every month, I can get an audit report of how many alerts went out for every different kind of service I'm monitoring and identify which ones might need tuning or tweaking or which ones might be problematic. Now, let me address some of the most common questions we get asked about scaling. So don't forget to go ahead and type your question into the webinar interface if I leave yours out here. Now, since our platform can be deployed as a virtual appliance or as a hardware appliance, what do we recommend for scaling? And obviously, this is going to be very dependent on your environment. And obviously, we'd be more than happy to have one-on-one discussions with you about your particular situation. But in general, the question is, does your virtual environment have enough capacity to spare? So monitoring is really a 24 by 7 by 365 kind of application, which means there's not a lot of idle time, which means it doesn't necessarily play nicely with others and share resources with other applications. So if the virtual environment is already oversubscribed, that is definitely something that might push you towards hardware, at least for your central console. Your service engines are a completely separate issue. Those could be deployed virtually in remote locations where you have excess capacity and where the need for the uh, compute or the storage resources on a service engine is nearly as intense. Another common question we get is how many service engines do I need? And each service engine can do performance and availability monitoring for about 3,000 devices on average. And flow or log performance is going to vary depending on the volume since those get pushed into the appliance. But it's pretty simple to add additional service engines as needed. And there's really no limit to how many service engines your OmniCenter can control because we're offloading processing to them. So easily several hundred or more. Now, the other question we get asked a lot is about maximum hardware capacity, and we have different hardware platforms, but the largest platform that we make is good for up to about 25,000 devices, depending on your configuration. Now, most customers find that it's more cost effective once you're over about 10,000 devices to deploy a smaller central appliance and then deploy several service engines to scale horizontally rather than centralizing all the data collection. But you've really got the flexibility to do either, just depending on what your environment's going to require. Now, I'd like to take just a moment to talk about who we are for those of you who haven't worked with us before. Netreo is in the middle of our 20th year, and we've been profitable since year one, with a proven track record in both public and private enterprise and a customer retention rate of 98% since day one. We've won Monitoring Product of the Year from Network Computing 4 years running, and we made the Inc. list of fastest growing companies for the last 3 years as well. And last year, after many successful years of being internally funded, we did a private equity transaction to gain additional working capital and resources, as well as access to some very experienced business experts, which allows us to grow even faster. So now I'm going to take a few minutes to address any questions that you have. So if you haven't already, please enter them into the GoToWebinar interface. And I'm going to go ahead and launch a poll as well. So if anyone would like us to follow up with them, you can use that method to let us know. So the first question is, how is Netreo licensed? So that's a great question. We've really tried hard to make our licensing as simple as possible. So it's really all done by the number of devices that you have. So each logical operating system counts as a device. So for example, a VMware server with 10 hosts, 10 virtual systems running on it would be 11 devices total. A stack of 10 switches that's managed as a single logical entity would still count as one device. So it kind of evens out, but it makes it easy to figure out how many devices we need, and we can scale that up or down as your needs evolve. And our enterprise licensing includes unlimited service engines as well. So you just deploy as many as you need to efficiently monitor your environment or handle things like isolated DMZ segments or secure network segments or VPCs that you want to monitor locally. All right, thank you for joining us today. I hope you've learned some useful tips to help you scale your management as you scale your enterprise. And as always, if you have any additional questions, please feel free to contact us at info@netreo.com, and we'll be sure to get back to you right away. Have a great rest of your day, everyone.